So we talked about classes with resources, and we say why it is important for us to know to know if a class has resources or not. I brought this up like this. So we said that when you are actually, it's loading. I'm going to go through the slides very quickly, kind of to review what happened, and then we're gonna see what happens. It's loading Microsoft. Give me 2 seconds. There we go. So we said that whenever we have two classes and the two classes have data outside of their scope, these two classes are in trouble when one gets assigned to another. When the two classes of the two objects of the same class, sorry. When we have two objects, when we have a class that has data outside of its scope, when one object of the class gets assigned to another one, what compiler does is that it blindly copies everything from one instance to another, and therefore the traces of the outside source for the destination becomes lost, and that becomes memory leak. Moreover, they are going to share the same resource with the other one because simply the address of the source is copied into that one. And that causes trouble when the destructor is called. The first destructor removes the resource apart from that memory leak. When the second destructor wants to delete the resource, it's already released by the first one, and therefore you're going to have a crash. And we said this is something, and I demonstrated to you that when we ran the program, when program runs almost normally, but at the end it crashes when the program exits. That's the reason, because when the object's getting destroyed, it cannot destroy what is about to destroy. Then we talked about same problem happening with copying. When you are copying an object and the object has resources outside of its scope, when the new copy is getting created, it copies everything from the old one into the new object that is getting created. And the problem over here is that we are not going to have memory leak, so it's not as severe as the other one. The other one, you had leak and crash. With copy construction, you don't have a leak because the object is new. And when copy construction is called, again, two classes share the same thing, and at exit time, the object again crashes. Now, we said the signature of these things are pretty straightforward. The signature, to be able to fix these things, we need to take over. We need to tell to the compiler, hey, don't do the copying, I'll do it myself. And we said the signature is pretty obvious. To actually detect something like that, for the copy construction, for the construction, I need to take over the construction that accepts another string as the same argument, and that becomes copy construction. And we mentioned two things must be strictly followed when you are creating a copy constructor. Number one, you must pass a reference to the copy constructor, because if you pass it by value, it becomes chicken and the egg. For copy constructor to get created, it has to do copy construction. Therefore, it's not possible. Number two, you need to make sure it's a constant to specify I am just copying and I'm not changing anything. Okay? For the assignment operator, it's the exact same thing. The difference is that the assignment operator overload returns the same object. Okay? And we said for good copying, this is what we do. For good copying, this is what we do. what happened? Let me just go back. There we go. So when you create a class out of another class, and I wrote you 4 different syntaxes that they all mean the same, which means at the moment of creation, you are assigning a class to an object of its own type. You are assigning object of an object of its own type. So I have data class A over there created with any constructor. Then data class B is created out of A, which means it copies an object of its own type. When something like that happens, what we need to do when the new object is getting created, instead of the compiler copying everything for us in a shallow way, I divide it in 2 different ways. I do the shallow and deep copy myself. What is shallow copy? Shallow copy is essentially copy what's inside the class and bring it over here. So bringing this M size 7 into M size, that's shallow copy. Anything that is inside, and you just copy it normally. Deep copy is to look at the resource, take the size, allocate memory, copy the information, make the data point to it. That's deep copy. Okay? So how do we do it? What we do is first we're going to allocate memory exactly to the size of the other object and make sure that the data is pointing to it. Then we'll copy every single thing that we have in the other one into this one, and then we do the shallow copy. So the shallow copy is done, and now I have 2 objects that are completely independent and they can work. That's good copying. When the structure comes, one gets deleted and the other one gets deleted. Everything has its own. We have no memory leak. Life is beautiful. Okay? For good assigning, that's the one that is tricky. And I'm extremely picky about this because many people do exactly what they do in the assignment when they are doing a construction. That's very wrong. When you are doing assignment, unlike construction, the object that is being assigned is not brand new. Therefore, it already has data. So you have to wipe out that data. So when you are saying B equals to A, B is being assigned to A. Therefore, it's going to get all the information of A. But it already has stuff of its own. So first, you have to take care of that. You should not do this in a constructor. You do this in a constructor, it means I have no idea what copy construction is. A constructor builds a brand new object. There is no already existing data, therefore you don't need to delete it. That's literally, that's wrong. There are only 2 things that is different between a copy constructor and an assignment operator, and this is one of them. Okay, 2 things you need to do in the assignment operator that you don't do in copy construction. But in here in the slides, it's not demonstrated. I'll show it to you in a code. So first you delete the data. Now that you delete the data, you follow what you have done in the copy construction, and you copy everything and shallow and deep copy and everything, and life is beautiful. Okay, so everything was over here the same, other than in the copy assignment, what we have done was to first delete the data. But when I look at the code, we'll see that there's more to that. Oh, so in here, what I'm going to do is remove the code that I have written for reusing, and I'm going to do everything as if these things don't exist. So we're going to follow the exact same instructions and do the same thing, okay? So because last time we reused our code, it looked very simple. And obviously, when somebody like me who've done this 50,000 times does it, I know what is good to do. But for a person who don't know, first you write it exactly as I told you to do it with the AI. First you do it. After it works, you ask AI to show you a more efficient way. Okay? So I showed you the efficient way first. Now I'm going to say how a student will do it. First thing first, the constructor that I have, the default constructor that I have. Do I need to do anything in a default constructor? Depends on what I want an empty class to be. In this case, I'm going to say my empty class is when my data is null and my size is 0. If that's the case, do I need to write anything in my constructor? The answer is no, because I initialize them over there. Those two curly brackets, that's a universal way of saying make these things 0. So this essentially means, the first one means, and the second one means, right? But who wants to type all those things? So instead of saying, so putting an empty curly bracket at the moment of creation only, putting an empty curly bracket at the moment of creation means default this thing when you're creating it, whatever that default is. If it's a complex object, its default constructor will be called. If it's a primitive type, the version of 0 making all the bits to 0 will be set. So for a pointer, it's null PTR. For a size t, it's 0. Actually, for a size t is not 0. For a size t is 0 unsigned. It's an unsigned 0. Because a 0 can have negative values, but unsigned 0 is 0. Okay? So instead of doing that, because I'm lazy, I like to do this. So let's actually copy this and comment it. And I don't care if it takes the whole session today, and I'm not going to get into inheritance, but this is an important moment, so I want to go through it in detail, so we review it. If you're bored, fantastic. Getting bored is underrated. When you're bored, your brain is super active. You're actually learning better. So being bored is good. Don't underestimate it, okay? So next thing. Whoop. I hate this automatic stuff of, I don't know. Anyways. All right, so these two lines means that. Because of this fact, I don't need to have a default constructor, but I want to have one. So what do I do? One, you can just write and don't put anything in it, right? Or you can tell to the compiler to create that empty thing for you. How? You remove this, and you say equals to default. Compiler will make an empty one. And yes.
Is it a better idea to always do that in the header file, or can we also say the same thing in the C file?
Never. It's not better. If you put it as syntax error, it has to be in a header file. You cannot do this over there.
Even if you say string, colon, string.
Because the header is the equivalent of a library file.
The whole idea is not to write it. If you're there, just write an empty one. Why do you want to type the full? Okay, we are C programmers. C programmers don't like to type. We want short, sweet stuff to be done with it. Okay? Are we good?
Yeah.
Okay, so number one. Number two, this structure was easy. We did it. I'm not going to do it again. I'm going to delete data. Please be professionals. When you're deleting data, don't set the size to 0. Why?
It's like washing out an empty coffee cup, basically.
Empty disposable coffee cup.
Empty
An empty
disposable
coffee cup, you should clean it, you bad boy. Because you're going to reuse it. That's the one that you have to set to null pointer, because you're going to reuse the cup.
Yeah.
If it's a disposable one, then you don't wipe it out.
Why are you deleting something that's not dynamically allocated?
No, you have to deallocate the memory, but it's deallocating it, and then it's garbage value.
So you are saying
want
why?
to set
You are
the
saying
garbage to
you're
zero.
wait. You are saying why you are deallocating it?
Yes.
It's not happening now.
Well,
Destructor by nature gets called when the object is going to die.
Yeah.
yes, but don't you just need to deallocate anything that you've dynamically allocated in the first place?
That's actually a good question.
Yeah.
Delete mdata has the logic in it to do nothing when you have nothing. So if mdata is null, let it be, doesn't matter. But if data has something, it will delete it. So essentially there is an if statement inside this delete. Says if data is there, delete it. If data is not there, you do not delete it, and that's it.
Automatically. Oh, is that,
There is nothing automatic in C++.
data is, no, it's
Nothing is automatic in C++. Yes, sir.
With uninitialized M data,
Hand up when you talk. Yes, go ahead.
with uninitialized M data, we cannot delete it. It's going to cause a problem.
Yes. Yes.
With the,
Exactly.
no, there's problems.
If you follow the golden rule of keeping unused pointers null, you're always in the clear. Just delete. And if you don't do it, there is no way to detect it. You're doomed anyway.
It's
Okay.
an invisible problem, basically.
Yes. All right. So let's continue. Now, the next thing we want to do is construction. So for construction, do I have CSTR here? I did have CSTR, right?
Yeah.
And it's already included, so let's do it. So now I want to do the data thingy over here. I'm going to say if the data exists, then do str copy. So I'm going to say, say mdata will be equal to new strlen, new character,
why is size?
strlen.
Sorry.
Let me finish and then we'll talk. strlen of data
Plus one.
plus 1. I allocate the memory, and after I allocate memory, I copy into mdata the data that I have. Yes, Julia, what's up?
Why is size T, sorry, why is M size OU, 0U?
0U means, so we have two different types of zeros.
Yeah,
You have a 0 that is a signed 0, which means you may have -1.
a 0 unsigned.
You have an unsigned 0 means there is no minus. This is the smallest thing possible. And because size T is that, I put 0U.
Is that an array, that size T, M size?
What are you talking about?
Well,
Curly bracket, that's not square bracket. That's the sign of initialization. That's curly bracket. This is curly bracket. This means this. And this means this. All right. Okay, so now we have copied everything, so this is done. And I forgot to actually set the size T, so I'm going to set the size T. I'm going to say M size is equal to the length and then plus 1. Anybody have any problem with this beautiful piece of code of mine? We good?
Yep.
Okay, so I'm kind of killing two birds with one stone. Bad expression, but hey. Okay, so I am setting M size to strlen, and then add 1 to it, allocate memory, and so on. Yes.
do you need to delete simple types?
Do I need to?
Delete simple types.
What are you talking about? What's
The object is structure. Do I need to delete, let's say it was,
I have no idea.
RM data is an array, so yeah, you need to delete that. But do you need, if it was just a double?
You delete what you knew. If you don't have a new, you don't have a delete. You
Yeah,
delete
yeah.
what you knew.
Yeah, yeah.
Okay.
Yeah.
Okay, actually that's a very common mistake. People just say delete everything. M size is not dynamic. There is no new. For each new, there is a delete. Okay, next thing is the copy construction, okay? So, in copy construction, what can I do over here? I need to,
You can use this.
so I'm gonna simply say string other dot mdata, right? Are we good? I just reused that code. Everything's good? Any problem with this?
You're calling the other constructor. So never.
You just got 2% for your final. I screamed at top of my lung at the beginning of the semester that you cannot call a constructor. What happened to you guys? Did I say that? And I screamed and I act like a crazy person. I said, you cannot, like, who was that thing? You shall not pass. I said, you cannot
Call a construct.
call a constructor. And I called it and everybody says, yes, yes, it's good. No, it's not. You are not allowed to call a constructor. If you want to recall it, put it in a private function. We didn't put it, so we have to rewrite it from scratch. Got it? You cannot call a constructor. So, what happens if I do it like this? Anybody can walk through this line of code for me? When copy constructor is called, what happens? Not you, you talked enough. Anyone else will give it a shot? So this is what happens. It's getting copied. The copy constructor get called. It comes over here. The constructor of string is called. A temporary nameless string at line 16 will be called that is a copy of the other. And as soon as the copy is done, at 16.5, it will die. So it's like a flash of light. For a second, a string is created and it dies. And it has nothing to do with this constructor. A string will get created, like this one. So in here, you're going to have a temporary object created and dying immediately. Yeah. Why? Because constructors are not functions. Their job is to build stuff. Yeah. You cannot call them. When you quote unquote call them, you are creating an object. You are not calling a function. Am I understood? We good? All right. So that's wrong. So what I can do over here is kind of play it simple. I'm just going to copy that. And I'm going to put it right over here. And in here, instead of data, I'm going to control H it. And I'm going to say in current block. Block. Where's block?
At the top.
Current block. I'm going to change it to other.mData. So now it's okay. And now you know why we had allo copy. Allo copy was written because of this, because it's a common thing that I'm repeating over and over and over and over. I did that. Now, for assignment operator, what I'm going to do. For assignment operator, it is exactly the same thing, but with some precautions. The very first thing that needs to be done is for the current data to be deleted, because it is not a new object, it's an object with an already existing data. So first, I have to delete the M data. That's the first thing I do. So first, clean up this object. And then after this, what should I look for? I mentioned it last time. I should look for crazy people. Self-assignment. So now I need to check to see, hey, if somebody's assigning something to itself, if that's the case, don't do anything. How do I find out? I'm going to say if address of me is not equal to the address of the other, do the copying. Other than that, just don't do anything. Somebody's copying something to itself, so nothing needs to be done. And at the end, I return myself out. Return reference of me out. We good? Hence, rule of 3. 1, destructor. 2, copy constructor. 3, copy assignment. These 3 must get created for an object that has data outside of its scope, so the copying stuff happens properly. As I mentioned before, you may prevent copying too. That's implementation 2. I could say copy constructor is equal to delete, which means I do not want this object to get copied, which means if they actually try to copy, they get a syntax error. Compiler stops the compiling. So you can either delete or implement. We good?
Is this on the midterm or not? Is this after the midterm? I thought
We are after midterm now, right? Aren't we?
Yeah, but it
No, what are you talking about? Week 5.
Yeah,
Okay, week 5.
week five stuff.
Week 5. This is weeks what? 8? 7? 8?
9,
Okay.
actually.
9? 9? This is 9, but this the topic is 8.
Oh, yeah.
I was sick one week, right?
Yeah, the
Oh,
topic
this is
was
week-
last year.
This is week 8. This is topic of week 8. Okay.
Okay.
All right. So that's that, and that's the whole thing about what we had, and now life is beautiful. So this is a review on rule of 3. Are we okay?
Yes, kind of. But I basically understand. I put this into my head last night, so I'm wondering if I actually need to know it, or I need to know it sometime.
So we're gonna go, now I'm gonna go look for some animals and I'll be back. Let me pause.
Yeah.
If you wanna have a break, you can go for a break. I need again another 5 minutes to set things up. Pause. Resume. Oh, I was recording all the time. I didn't stop the recording in the Teams. So in the Teams, you're gonna see a big gap of me talking about nonsense. So now, okay, so but in YouTube, it's gonna be fine. All right, so I'm writing my encapsulation of an animal. What's encapsulation? You have the microphone.
Encapsulation is to basically hide the methods within the class.
Wrong. Pass it through.
Encapsulation?
Mhm.
It's when you. Oh, I forgot the.
Seriously?
Put data and behaviors together. Put
Data and behavior together and 1% for final. Thank you. So remember these percents that I give you. You're going to get it, okay? Pass it. He already talked. Give it to someone else. Give it. No double credit. Okay. So, and next time, sit here, not back there. You think they think I have some kind of a disease. They always go sit at the furthest corner possible. Okay. Come here next time. All right. So this is my encapsulation of an animal. So for me, an animal has a name, it can act, it can move, it can make a sound. That's what I call an animal. From my perspective, in my application, that's what animal has. Be good? I wrote the copy construct and copy assignment for no reason. It doesn't need that at all for what I'm about to teach today, but because we are just coming from classes with resources, I put that one on just to show it. And this one, actually, Julia, this one doesn't need a copy constructor. Why? Everything's inside the animal. Name is not dynamic. That's just a waste of time. The reason I put this thing is so you run it, it shows some messages, you know when they are called. Okay, it's a good practice. Pass this thing by value, pass it here or there, and see how it works, so we can remember how it works. So how and when copy construction and copy assignment is called.
Isn't a concept name nameless? Isn't that the copy constructor elements what name is? You don't give it
Okay, so we're gonna go. Wow, this is an old one too. Doesn't matter. You look at the thing, SDDS. That's when the school was called SDDS. Now it's SCPA. So the S. Actually, I can change it. I can go Control H. Oh, Control Z. So in here, going to SCPA. Or we call it Seneca now, right? We can do Seneca. Because it kept changing, and we finally said, the heck with it, let's make it Seneca. And it's not going to be whole word. And we'll match that one, and it's going to be entire solution, sure. All right. Good. So now it's Seneca. Oh, shoot, now we have SDDS. Okay, let's name space SDDS. Control H, change that one too. SDDS, I'm going to make it Seneca, and this one has to be whole word. Are we good? Entire solution, change. Done. Okay. So, 19 of them. Fine. So, as I was saying over here, I am creating an animal in here. And as you see, the constructor of an animal sets the name using the modifier that we have, right? And it gets the name whenever it needs using the query or getter. So the animal constructor, if the debug is on, if I have the debug flag on, it's going to show messages. If the debug is off, it's not going to show the messages. I created a flag in the utils. So how did we create that flag in utils? Let's talk about global variables. We learned in IPC 144 that if you put a variable at the top of a file, at the top of a file, let's put it over here, so it adds it over here. So utils.cpp. We said that if you create a variable outside of the class, that variable becomes global, right? Remember that? So debug becomes global, but it's not really global because it's only global for utils.cpp and it's not visible anywhere else. You follow this? This debug variable can only be seen in utils and nowhere else. So if in C language you had a function that you wanted to be seen outside of its file, what did you add to the function? And if you don't answer this, we are really sad. Okay. So you have a function in C language. You write a program.
Include.
No.
External.
No. Because I didn't say, I said in C program and people are answering. Okay. When you create a function and you want to use that function in another file, what do you do? No. What extern? You don't know even what the stick. Shush, you don't talk. Tell me. You think you sit back there, I'm not going to ask you? In C program, you write a function in one file and you want to use it in another file. We have to add something at the top of the another file. The other file. Yeah, but what do you have inside the include file? The header file. That makes the thing available. Okay, see, that's why I said, remember I said when I said when I was marking your midterms, you sucked at IPC, not OOP, right? You guys have forgot what is a function prototype. Yes, prototype. You add a prototype of a function somewhere else so you can use that function. That's what goes in a header file. In a header file, you fill it with prototypes of the functions you have in another file so you can, therefore, yeah, but you didn't say prototypes.
So it's not, it's a different concept, but it's like forward declaration. No, but no, it's you put the,
Yeah.
in a way.
Forward declaration is a prototype for a class.
Yeah.
And
You can put prototype in another file to make it visible.
extern is a prototype for a variable. So when I write extern bool debug, I am not creating a variable here. I am telling, hey, in one of the files, there is a global variable called debug that I want it to be accessible everywhere. Any file that includes utils.h will have this. Therefore, they will have access to the debug variable. Got it?
Yeah.
So to make a variable, and that's going to be in your next quiz, for a variable to become accessible in other files, you need to use extern as prototype of the variable so it can be used other places.
Oh, I was wrong.
Now, pardon me?
Was I right then? About extern? You just said extern.
I asked a question about a function, and you said extern, you bad boy. So, next, look at this. I put all the CSTR functions inside the utils class. You see that? Everything I had inside the utils class, not standing by itself. Then I instantiate the util class, call it UT. Here, you see that? Yeah. And I extern it over there, which means in any file, if you type ut dot, all these functions are going to appear. So I don't have it standalone anymore. My functions are in utilities class now. I have a class utility that I can carry around like a toolbox with me. They are not all in a file like a mixture of things that I cannot find. You simply say ut dot, and you're going to see all the utilities available. Capiche? Are we good? Comprende? All right, so now Now that we have, and I make that one extern too, you see that? Which means it's available everywhere. You've been using this since the beginning of the semester.
Yes, Mr.
With what? Not the extern. You are using an object that has been extern in a header file.
See out?
C out, C in, C error, C log. All these are instances of iStream and OStream that are instantiated in IOStream header file and in IOStream body and extern in IOStream header file so you can use them. That's why you have C out everywhere. It's because it's extern somewhere. Got it? We good? All right. So now we can actually go back to our animal. So now let's go to the animal thingy. So that's why in the animal, when I write over here, if debug, so if the debug is on, I'm going to see all these messages happening. If the debug is off, they're going to go all off. So therefore, right now, I want just as an example in here in my main.cpp, I am saying show animal, and I'm passing the animal by value, as you see. And if the debug is true, I'm going to set it to false. So I'm saying Seneca debug false. And when I run the program, this is how the program runs. 3 years later, when it compiles, of course. Come on, you can do it. There we go. So this is the execution, and this is the thing. And let me just close these so I can see. Why it went up? Don't go up. Windows 11. I don't know. It's. Oh, give me a break. Really, 3 years later. Okay. He's looking at me seriously. He's looking at me in a very, like, I'm like, did I do something wrong? Okay, so, so take a look, please. So it comes over here, animal Fluffy is created, and it says act like an animal, move like an animal, sound like an animal. Then I'm passing the animal to show animal by value. It goes right up in there. And it did few stuff that I didn't want you to see, but it goes up into the animal thingy, and it's going to show the animal and return the animal and come back in here, and we're done. So that's what happens in our application, right? Now, to see actually what happens behind the scene, I'm going to set this to true. Remember, 4 lines of output? But what happens behind the scene is, oh, sorry, not that. What happens behind the scene is, where is F5? This is F5. Woo, okay. Because I passed the A over here to animal as by value, what happens at the argument is actually this. Animal X is equal to A, right? Because it's passed by value. Assignment at the moment of creation is copy construction. Therefore, you'll see over there creating a move, copying Fluffy the animal by setting to Fluffy. Then shows the Fluffy over here. Now I'm returning an animal, right? To nowhere. But because it's returning by value, another one is being copied. And now that is dead, and then the other one. So what you see is one, but you have several animals created and dying just because you were sloppy in your code. You just pass things by value where you were supposed to pass it by reference. So if I just go over here, do this, and this, and run the program again, it will do exactly the same thing with nothing being created. That's why you pass things by reference. Has nothing to do with inheritance, but that is why I added the copy constructor and copy assignment. Please play with this code and try to pass animal here or there and see what's being called. We good? So we know an animal can act, can move, and can make a sound. Are we good? All right. Close all tabs. Now I like to have a cat. Set as startup project. The animal is the same animal, but of course I removed the copy constructor stuff because that's not my concern at the moment. So all I have over here is an animal that has a name. Forget about line 7 that I have protected. I'll talk about it later. Assume that protected is private. Okay? So I have an animal, it has a name, animal, yada, yada, yada. So it does exactly the same thing. Now I want to create a cat. What is the difference between a cat and an animal? Cat has one extra thing. Can anybody say? Huh? No. It has number of lives. A cat has 9 lives, right? Right? A cat has 9 lives. But an animal dies only once. So now if I want to create a cat, what do? I start creating an animal from scratch? No. What I will do, I'm going to say cat is an animal that has number of lives. Got it? That's inheritance. It means I don't need to set a name for the cat. It comes with the animal. I didn't even need to set any act or move or sound and whatever. If I didn't do that, if I didn't set the act, the move, and the sound, cat would act like an animal. So the ones that I do not want to change, I do not need to even implement. As you see, there is no move in here, which means when I tell to a cat to move, it's going to move like an animal. But when I tell to the cat to, what should we call it, to act, this is not overload, this is override. Override means cat act hides the action of the animal. When you tell to cat to act, it will forget how it acted like an animal and it will act like a cat. So you can modify it. That's how you reuse design. Exactly as if you want to create a motorcycle out of a bicycle. There are so many things that are similar that you do not need to change. How to steer, you do the exact same thing with a motorcycle as you are doing with a bicycle. You don't need to change that. If number of wheels is exactly the same, there are 2 wheels aligned exactly, so structure is exactly the same, but the mode of movement is different. So you add an engine and you say instead of pedaling, you have to increase the throttle. So you see where I'm going, right? You modify things and you keep few things the same. So this is the syntax for inheritance. By creating a class and adding public animal, this public for us and even in OOP244 remains public. There is nothing other than public. You don't know what does it mean to do private inheritance or protected inheritance. You just leave public. But for the rest, I'll explain. Go ahead.
So does this cause polymorphism?
No.
This
This is called inheritance.
So does it cause polymorphism, like this inheritance?
The polymorphism has 4 different things we're going to learn at the end of the semester. We have coercion. We have universal and ad hoc. Universal is real polymorphism. Ad hoc is fake polymorphism. First of all, polymorphism is doing the same thing in different ways. Okay? Doing the same thing in different ways. The very first polymorphism, you did it even in C language, where you say you wrote A plus B and you didn't care if the A or B is integer or double. Plus just happened. So it acted in different ways. That was polymorphic. We call that coercion. The other type of polymorphism is overloading, which essentially you have a function with different types of arguments. So you think it's polymorphic, but what compiler sees for the name is the name and the argument. You have add int and add double. Therefore, the names are really different. when you look at it closely, polymorphism goes away. Okay? Inheritance causes a type of polymorphic action that we call universal, that you still don't know. We'll go through it and you'll see. But real polymorphism is one of the side effects of inheritance, but it has nothing to do. It is one of the features. It's not. So essentially, I can say universal polymorphism depends on inheritance, but still these are completely two different things. It has nothing to do. So you cannot say inheritance is polymorphism. I would say no. Inheritance causes universal polymorphism. Okay? Thank you for packing your stuff so I know my time is up. Okay, so, because I see, backpack is going on. I know, I'm joking, you're good, thank you. Okay, so it's 1:30, class is over. I'm gonna start everything from scratch, but I leave the code over there for you to see. So I'm gonna leave the animal and the cat, well, remove the rest, okay? And then afterwards, we're gonna, by the end of it, we're gonna have a tree of inheritance of animals everywhere. You'll see that. Okay? So let me, pardon me? I'll add a penguin, for heaven's sake. Actually, you know what? No. You cause it yourself. Your responsibility would be at the end of my lecture to add a penguin to the.
I'll do that.
Okay, you.
Can I just photograph this before you delete it? You can delete. I want.
I'm not deleting anything.
Oh, you're gonna push exactly this?
Everything goes, thank you, into the
I thought you
replay.
said you were gonna delete all this.
Nothing ever gets deleted, ever.
Tell me about it. Don't post yourself on the internet.
Cheers. Remove. How do I remove this? Remove. Okay, so let me save this.
Just let me photograph it, will you?
Doesn't make any difference. Sure, photograph. Oh,
You already handed in your thing?
Yeah.
Just hold it up on the screen there for a bit.
I want to ask something. So, in the
More questions.
in the destructor,
I'm not a multitask person.
I know.
Let me finish my thing, then I'll talk to you as much as you want.